We all know how important it is to have accurate time in your devices. In macOS, Linux, Windows, they all have different ways to set the automatic date and time. Under the hood, they all rely on a protocol called NTP, Network Time Protocol. So in this video, let's discuss NTP and how it works in different UniFi routers. In this video, we will see how NTP works in action using Wireshark. Then we can explore our familiar operating systems to check the so-called clock stratum for the default time servers they use. Then we will discuss in different UniFi routers, for example in the earlier UXG Pro or the relatively recent UXG Pro, how NTP is supported differently and how to make it work together with the DHCP option 42. Okay, let's get started. To make NTP works, we need server and client. So in this video, we are going to focus on NTP client only. In the lower part of the screen, in the left side, let me start capturing using Wireshark. As you can see, I already set the display filter to NTP. Then in the right side, let me run the command as NTP. It is a simple NTP client against the time server for macOS, which is time.apple.com. In the left side, 2 frames are captured. Stop capturing. Let's examine the 2 frames. The first one from this particular Mac machine, the destination is time.apple.com. If we check the details inside the packet under the NTP section, we can see the first timestamp. In the diagram, I draw the simplified steps for the whole NTP query and the response process. In the first step, the device sends the NTP message with the first timestamp, as you can see in the Wireshark. This is the timestamp from the client device perspective. What's the time it has now when it sends out the NTP message? When the server, the time.apple.com, it receives the NTP message sent from the client, it will have the second timestamp, which is the timestamp it received the packet. Let's check the second frame. You can see multiple timestamps. This one, a region timestamp. This is the one sent from the client machine, the T1. The receive timestamp is the T2 for the second step. And then in the third step, the server will reply back with a new timestamp, T3, the timestamp that the server sent out the reply. As you can see in the second frame, it's the very last timestamp, the transmit timestamp. So in the reply from the server, you can see the T1, T2, and T3. And then once the client receives the reply, it will have another timestamp, which is T4, for the time that the message arrived at the device. From the client clock's perspective, we don't see T4 in the captured frame because only the software, it knows T4, right? That makes sense. It has all the 4 timestamps from T1 to T4. Then it can do all sorts of calculations. For example, how to calculate the delay by using this 4 stamp. How to calculate the offset is another formula by using the 4 timestamps. By doing calculation, by using the different timestamps it received, the client will automatically get the correct time and then set its local time. That's how NTP works from the client perspective. Next, let's talk about clock strata. There are different levels of NTP servers and they may have different so-called stratum. The larger number means they got the time synchronized from the smaller number servers. For stratum 0, normally they are, for example, atomic clocks. They are most accurate. Then if you have a larger number stratum server, that means it will be relatively less accurate. When you set the automatic time synchronization in your operating system, you may assume it's guaranteed they get the accurate time, right? But how accurate the time is, you may be surprised because you may connect to a server with totally different stratum than other operating systems. I have 3 different clients running different operating systems. Let me start the Wireshark capturing for each of them. macOS, Debian Linux, Windows, they all started. Let me start with macOS. Enable this set time and date automatically. Okay, something's captured. In Linux, disable, enable again. Yeah, something's captured. In Windows, force asynchronize. Okay, let's briefly check the stratum for each one of them. Let's check the reply from the time server for macOS, the second one. You can see this peer clock stratum 1. For Linux, 2. For Windows, 3. Okay, so it's interesting, right? I'm not really saying, okay, 3 is bad, 1 is good, because for home user or your application is not that critical. It doesn't really matter, right? So 3 is already very accurate. But I just want to show you, don't take it for granted that your operating system's default time server matters when it comes to the accuracy of your device time. Before talking about UniFi, let me briefly mention the NTP pool because later we will see it's also important in UniFi routers. You know, the accuracy of time is important for your devices, but if the way to get accurate time is completely depending on the NTP server you set, and if that server fails, you are stuck. To achieve some kind of high availability and load balancing, here comes NTP pool. Let me briefly show you. For example, in the right side, let me ping one of Ubiquiti's NTP pool. Okay, you see this IP address, right? Let me queue it, ping it again, the same address, ping the third time, the same address. The reason all the 3 pings they used the same IP address is simply because the DNS result is cached locally. In the left side, let me do it in another way. Let me dig the domain name. So you see this 4 different IP address, right? Run it again. This time, if you compare to previous result, you can see they are the same 4 IP addresses, but in different sequence. If I do it again, same thing happened. The same 4 addresses in different sequence. The reason is the mapping between the domain name and IP address is done in a round-robin way. Each time when you try to get the IP address, you may get a different address. So in that way, if one of them fails, you still have a chance to use the other working ones. So later we will see how it will impact the UniFi routers. In the second half of the video, let's focus on UniFi. For UniFi routers, the recent ones, for example, UDM-Pro or UXG Pro, they use totally different backends as the previous generation, for example, USG Pro. The different backends lead to different ways UTP is supported in UniFi routers. First, let's talk about the old one, the USG Pro. So in the upper right, you see the UniFi network controller connected to a lab environment using USG Pro. Go to any VLAN, for example, the default network, then go to DHCP management. You can see all the familiar options, including this one for NTP server. But this part is only used by DHCP to inform the clients to suggest them what's the NTP server they want to use. It's not for the NTP server itself provided by the UniFi router. If you explore all the possible settings in the UniFi network controller, you simply cannot find a NTP server setting. However, in the lower right part, let me simply run this command as NTP against the USG Pro's IP address. Yes, I'm able to get the result back. This confirms the router itself does run a NTP server, but we cannot find the setting here, right? In fact, we do have the setting, but it's hidden in the old UI or legacy UI. So let me switch to the legacy UI. Okay, in settings, go to services. See, NTP is part of the available services provided by the router itself. And then it lists out 4 pool domain names for Ubiquiti. The setting is there, but where is the server itself? In the lower left, let me SSH into the UXG Pro. Let me run the Linux command netstat and to check port number 123. It is being listened for every single VLAN. What about PS command? The Linux NTPD, which is the daemon for NTP, it is running. Then let's see the NTP configuration under etc folder, NTP config. This is how we configured in the UniFi network controller as well. See the 4 Ubiquiti pools. They are also here. In the end of each line, you see the iBurst. My understanding of this parameter is in the very beginning, when the NTPD try to establish the communication with those NTP pool servers, there will be multi back and forth needed just to speed up the process. The iBurst is used to finish the initial process faster. Then let's see how we can even use the default provided NTP server within the UniFi router. As you can see in the diagram, for a given client, for this particular USG Pro, the client may have 3 different ways to set the time server. It can set the time server to any available server on the internet, or because the router runs its own time server, the client can manually directly set the time server to the router, or the way we are going to explore in this video. For DHCP server, there's a DHCP option 42, so the server can inform the client to suggest the NTP server. In UniFi Network Controller, for example, for this default network, go to Advanced Menu, DHCP Service Management. As you can see, at this moment, the NTP server is disabled. This is the default setting, which means DHCP server will not suggest any NTP server. So the client is on itself. So let me use the Debian Linux as an example to see in this situation what's the NTP server it will use. So in the lower left, I run a Wireshark monitoring the one part of the router. Start capturing. As you can see, I already filtered on the NTP. Then in the right side, see it has the automatic default time turned on, right? So let me force a refresh. Let me disable it, then enable it again. See in the Wireshark, something's captured. Let's see what happened. The Linux client reached out to this IP address and the protocol is NTP. It simply tried to synchronize the time. And then the server replied, nothing special. What is this IP address? Where the Linux even get the IP address? In the right side Linux, let me run this command, time date control, show time sync. Here it gives the NTP server it is using now. Just some background. By default, Debian 12 is running the systemd time sync D to synchronize the time. So we know it's using this pool, right? It also recorded the server address. See, this IP address is exactly the one we see in the left side Wireshark. Before we make any change in UniFi Network Controller, everything is straightforward. We understand why the Linux client will reach out to this NTP server, right? So now let's try to change the NTP server. Because we just investigated in the backend of the router, we confirmed there is a NTP server running inside the router, right? So then this time, let me set the NTP server to this router's internal NTP server. Let's see what's the different behavior for the Linux client. apply changes. In order to easily refresh the DHCP and time sync change, I simply rebooted the Linux machine. In the time setting, let me disable the automatic date and time and re-enable it. You can see nothing's happened in the Wireshark. Let me try again. Disable it, enable it, nothing, right? So why is that? Let me run the same command as the one we ran before the DHCP change. Time date control, show time sync. This time is different. So the NTP server is different. Now it reflects the DHCP change we made in UniFi network controller, right? But you may ask, then why when we re-enable the automatic date and time, the Wireshark didn't capture anything? Think about it. Before the DHCP change, the Linux machine is directly connected to the Debian's NTP Pro time server. So no matter when you want to refresh the date and time, of course, it will force the communication with external time server, right? But now we are running our own NTP server within the UniFi router. So only when it's needed, it will talk to the upstream time server. But apparently, when you simply want to refresh the time in your local network's client, it doesn't need to, because the time is already accurate enough. It doesn't need to refresh with the upstream time server. That's why no matter how you want to refresh the automatic date and time, you may not see the NTP message you expect. We can easily force the packet using the command line. So let me run it. You can see in the left side Wireshark, we still don't capture anything for the similar reason, right? By the way, what you see here, they were not from this Linux client, so they are not relevant. This video is too short to cover all the details. I'm going to have a dedicated video talking about in different operating systems, whether or how to utilize the DHCP option 42. Next, let's move on to more recent UniFi routers. In this video, let me use UXG Pro as an example. In the network controller, even if we switch to the legacy UI, go to settings, for services, yes, you still see the same NTP service here. You can even make changes if you want. The system doesn't warn you anything. But does it mean NTP works the same way as in the old USG Pro? Let's find it out from the backend. Let me log on to the UXG Pro. Let me see whether we even have the NTPD process running. No, it's not running. We don't have the NTP service at all on the UXG Pro. Just to make sure that's really the case, in the right side, in the NTP client, let me try to get time from the UXG Pro. See the error? No eligible servers. We already confirmed, no, the UXG Pro doesn't have native NTP server. You may think whether NTP server is running in the UniFi router, is that a big deal? Because anyway, the DHCP setting is still there. You can still set whatever time server you want in the option 42. Then your client will still get the automatic time setting, right? For example, for the USG Pro, the old UniFi router, yes, it can run a NTP daemon, but anyway, it has to point to a external real NTP server, right? Why not you simply change the DHCP option so that it will also point to the same NTP server, right? Can we do that? Let's try it. In UniFi network controller, go to setting, networks. For example, let me pick the default network, advanced menu, DHCP options. Then let me enable the NTP server. Here, let me use the ubiquitous NTP Pro domain name we just saw in the legacy UI, right? See the error? Please enter a valid IP address. Move the cursor to the tooltip. You can see this cannot be a FQDN. It may take you some time to understand why it even has the limitation. In fact, this limitation is not Ubiquiti's fault. It's by the RFC standard. So in the RFC 2132, which is for DHCP options, in the section for NTP, you can see what the DHCP server can provide is a list of IP addresses. You cannot use domain name, the FQDN. Then you may think, okay, it's not big deal. We can easily get a IP address for the domain name, right? For example, let me go to the lower part, the Linux client. We can dig the domain name. We got 4 IP addresses back, right? What if we simply pick a random one and put it here, right? So technically, yes, nobody can prevent you from doing that. But first, it will completely defeat the reason why we even have the concept of NTP pool. You are hard coding your NTP server to a fixed one, and you will lose the high availability and the load balancing. And the second thing is, it's a very, very bad practice when you try to get the service from public time server pool, but you only request the service from a fixed IP address. Don't do that. We do not want to fix a IP address here. Then you may think, does that mean for UXG Pro, we don't have any option to utilize the router's NTP functionalities? Not really. If we compare the USG Pro and UXG Pro, the real difference is for USG Pro, it has a NTPD running. For UXG Pro, for some reason, Ubiquiti made decision it does not run NTPD. Even though theoretically it's simply a Linux, you are able to run NTPD for sure, right? If Ubiquiti doesn't support it, we can take alternative way. For example, it's just a very simple NTP daemon. We simply run it in a separate Linux machine, right? Let me do that. In the lower left is a standard Debian 12 Linux. I simply installed the NTP package. For the default ntp.config file, I added the Ubiquiti's NTP pool as the upper level NTP server. Then in the network configuration, I disabled DHCP. Yeah, that's it. So the whole process may take you 1 or 2 minutes. Then you have a local NTP server up and running. In the UniFi network controller, this time, instead of using the hard-coded IP address for NTP pool server, let me simply point it to our new local NTP server. Apply changes. Done. Let me run the Wireshark in the local network on this Linux client. Start monitoring. Add the display filter for NTP. Then let me force the date and time synchronization to see whether the local Linux client will send the NTP message to my local NTP server. Disable the automatic date and time. Enable again. See, 2 simple messages. The first one from this Linux client to the local NTP server we just set up, and then we got the reply back. So in this way, even though UXG Pro has a annoying missing feature in the backend, it doesn't run NTP server, but we can simply set up one very quickly. Then we have all the good NTP support again. Okay, I am still debating whether I need to have a separate video to show in different operating systems how the NTP client works. Let me know in the comments, because I don't know whether there will be a lot of viewers for that topic. Okay, thanks for watching.